The lymphatic system cleans the interstitial fluid and returns it to the bloodstream. This is interstitial fluid. It is about to be sucked up by the lymphatic capillaries.
Whoa!
From now on, the interstitial fluid is referred to as lymph fluid. Lymph fluid now flows through the lymphatic vessel. The lymph fluid now travels to the lymph nodes, where the lymph is filtered and rid of debris. The macrophages in the nodes destroy the microorganisms.
I do macrophage. Thanks, bud.
The clean lymph now travels back to the lymphatic vessel, which leads to the large lymphatic trunk. Lymph eventually ends up in the collectory ducts. The right lymphatic duct drains from the upper right limb to the right side of the head. The larger thoracic duct receives lymph from the rest of the body. The fluid drains into the subclavian vein, which merges with the vena cava. The process starts all over again.
Now we have an evil pathogen that is trying to invade Joey. Let's see what it'll try. First, it tries to enter through the eye, but acidic tears, also known as lysozymes, kill it. Then, it tries to enter the nose, but mucus traps it, and it doesn't successfully invade Joey.
Can't get through this one.
Finally, the evil pathogen finds an entry through a cut in the skin. If it landed anywhere else where the skin was fine, this wouldn't have happened. As the pathogen begins to invade cells, a macrophage bumps into it, and detecting it as a foreign cell, engulfs it and takes its antigens. This initial encounter causes inflammation of that section, bringing more white blood cells and starting the specific or acquired defense.
White blood cells unite!
Now that we have a macrophage that phagocytized the pathogen and excreted its antigens, the specific defense can begin. An inactive T helper cell touches the antigen and the macrophage presents and activates. The T helper cell then releases cytokines, which will carry out multiple effects. The cytokines will attract more leukocytes to the infection site and will activate B cells. B cells activate in two ways. Some of the B cells develop specific antigen receptors that can detect that pathogen from now on and become the memory B cells. While the rest of the B cells transform into plasma cells that produce antibodies to kill the pathogen.
What are you doing here? Take these antibodies.
No! No! No!
Now that the plasma cells are handling the pathogen, Joey needs to get rid of its already infected cells. This is where killer or cytotoxic T cells come into play. They bind to human cells that have the pathogen's antigen and dissolve the membrane of the cell to kill it.
Alright, that one's good. Uh-oh, I don't like how that looks.
The pathogen's back. After breaking through the skin, it again attempts to infect the body.
Hey, I remember you.
Because the antigen receptor matches the receptor of the pathogen, the memory cell recognizes the pathogen and knows to change to a plasma cell to destroy it.
I'm a plasma cell. Hey, take these
No!
antibodies.
Not again! Not again!
After the cytotoxic T cell kills the infected human cells again, the pathogen is done for good.
Really? You're infected again?